Good morning, my dear students. Continuing with our discussion on linear correlation, let us try to interpret the value of a correlation coefficient. As you have already learned, correlation coefficient shows the degree and direction of the linear correlation between two variables. When you interpret correlation coefficient, please keep in mind that we are not explaining the cause effect relationship between the two variables, but we only indicate the sign and the degree of the linear correlation between two variables. When r is equal to 1, how do we interpret it? When r is equal to 1, we can say that due to change in one of the variables, there is a change in the other variable too in a certain proportion and in the same direction, then there is perfect positive correlation, or r equals 1. Whereas in case of r is minus 1, we can say that due to change in one of the variables, the other variable changes in the opposite direction in a certain proportion or in a constant proportion. That means when one variable increases, the other variable decreases in a particular proportion, and when one variable decreases, the other variable increases. So it's a case of a perfect negative correlation where r equals minus 1. And when r equals 0, we can say just that there is no linear correlation between the two variables. There can be a non-linear correlation possible between the variables, but it is safe to say that there is no linear correlation between the two variables. That is the point we have to understand here. Therefore, r lies between minus 1 and plus 1. It can be 0, 2. When you interpret a correlation coefficient as partially positive or partially negative, it can be any value above 0 up to 1, less than 1 in fact, and if it is if it is partial negative correlation, it can be value less than 0. Here it is a case of partial positive correlation or partial negative correlation depending on the situation, and we can say that when there is high degree of correlation, negative correlation, it is minus 1, that is perfect negative correlation. When it is 0, there is lack of linear correlation, and when it is positive 1, there is perfect positive correlation. Okay, those are some of the important points. And when you work out the sums on Carl Pearson's product moment method by any formula, the answer by all these formulae should be the same. Okay, so you apply any method depending on the case, and you are supposed to get the same answer as do we get in other formula cases too. Now let us just see some of the illustrations. Illustration number 5. Here there are two columns, reading hours of last 3 days and marks obtained in the examination. Those items are available. Okay, and what we have to do first is we have to find out the mean x bar and y bar. Here in this case, x bar is sigma x upon n, which is 231 by 7, which is 33, and mean y is equal to sigma y upon n, which is 504 by 7, it's 72. So both the values of mean are integers. So when they are integers, we can use the direct method, where what we do is, as in the third column, x minus x bar and y minus y bar are directly found out. Then x minus x bar and y minus y bar are located. Then x minus x bar the whole square and y minus y bar the whole square. These are the 5 columns required to work out sums on linear correlation by this method, and find the summation of all this. Then just apply the equation. So we get the formula sigma x minus x bar into y minus y bar upon sigma x minus x bar the whole squared into under root of sigma y minus y bar the whole squared. We get the answer as 0.96. You can say there is high degree of positive correlation in this case. Okay, that is the interpretation. So this is how the sum is worked out. Then take the next one. Marks in Gujarati and marks in statistics are given. Here again x bar is an integer 69, y bar is 90, which is again an integer. So using the same formula we can work out it: x minus x bar, y minus y bar, x minus x bar into y minus y bar, and x minus x bar the whole squared, and y minus y bar the whole squared. Okay, work out it like this, and now we apply this formula: sigma x minus x bar into y minus y bar upon square root sigma x minus x bar the whole squared into square root sigma y minus y bar the whole squared. Okay, there we get r is equal to 0.16. okay, which is a value very close to 0, so there is a low degree of correlation. Okay, that is what we can say. There is a low degree of positive correlation between the two variables given. Now we are given another case where these values are appearing. Just try to find out the mean. Mean is equal to 6.67 and y bar is equal to 9.67. That means they are not integers, they are decimal values or fractional numbers, and we get, as these are numbers which are not integers, we can directly apply that formula xy method. So what you do here, x and y, x into y, x squared and y squared, only 3 columns required here, and get the summation of those values. Then we get, apply the formula r equals sigma x minus r equals n into sigma xy minus sigma x sigma y upon square root of n sigma x squared minus sigma x whole squared into n sigma y squared minus sigma y the whole squared. And when you work out that, the final answer comes to r is equal to 0.94. r equals 0.94, which is close to 1. So there is high degree of a positive correlation. Then next case is minimum temperature and demand of heaters given. Okay, x and y variables are available. So let us see how we proceed. Here mean is coming to 5.8 x bar and y bar is 13. So one of the means is an integer, whereas the other one is a fractional number. So we have to apply this xy method again. So xy, x squared, y squared, work it out, and we get the value minus 0.97. So there is high degree of negative correlation. Okay, that is the implication. So accordingly we work it out. Now you can do sums from 2.2 exercise. Okay, and in case you have any doubts, please ask me.